Welcome to the Deep Dive, the show that takes a stack of incredible research, articles, and insights and, well, distills them into the knowledge you really need.
Yeah, the essential nuggets.
Exactly. And today we're looking at something huge. It's not just another tech trend. We're seeing a profound, really fundamental shift happening right now in the very structure of artificial intelligence.
That's right. It's not just AI getting smarter, which, is happening fast enough,
Right.
but this is about how AI is being fundamentally reorganized, its whole computational being, if you like,
We're moving from what most people probably think of as a single big AI brain.
like one massive model.
Yeah, to these entire ecosystems,
Mhm.
interconnected autonomous entities working together. It's a pretty radical architectural metamorphosis.
That's a perfect way to describe it. And it's not just like an upgrade. This is a qualitative leap, a different way of building AI entirely.
So today we're taking a deep dive into AI's unseen future unveiled, navigating the emergent frontiers of agentic AI.
And our mission, really, is to unpack this massive architectural change. We want to explore what it means for, well, how AI is designed, how it actually thinks,
If we can call it thinking.
how it processes information, maybe, how it's going to be governed, that's a big one, and of course the profound implications for us, for human creativity and the future of work.
And we're basing this on a really comprehensive report. It acts almost like a roadmap to these, well, these unseen territories.
So think of this as your shortcut. You're getting the condensed version, the key insights, to get you well informed on something that's, frankly, set to redefine our world.
Get ready for some aha moments, because what we're about to explore, it's not just super technical, although there's tech involved.
Oh, yeah.
It's deeply relevant to how you listening will interact with and understand AI going forward. In your personal life, definitely, but almost certainly in your professional life, too.
Yeah.
So let's unpack this. Let's start right at the foundation of this paradigm shift. Okay, so we're talking about this fundamental restructuring, moving away from those big monolithic models
The GPT-4s of the world, yeah.
to something more dynamic, more like a collective. It feels like a really big deal.
It is.
For our listeners, maybe let's start with the basics. What's the crucial difference they need to grasp between, say, a simple AI agent and this bigger concept of agentic AI?
That's uh, absolutely essential. It's the starting point.
Yeah.
So when we talk about AI agents, we're talking about the individual units, the building blocks.
Uh-huh.
These are autonomous decision-making entities. Think of them as, I don't know, independent actors,
Right.
like a specialized worker on a team.
Right.
Each one can perceive its environment, its specific little context, make decisions based on that, and then, execute actions to achieve a very specific goal.
So an individual agent might automate one single task, like filtering emails or something.
Exactly. Filtering emails, scheduling a meeting, pulling a specific piece of data, a discrete task. That's an AI agent.
Okay, so that's the agent. What about agentic AI? That sounds broader.
Much broader. That's the subfield itself.
Yeah.
Agentic AI is where the real complexity and, frankly, the power comes in. It's focused on the design, the orchestration.
Like conducting an orchestra?
Precisely.
Mhm.
And the governance, how you manage them, of these individual agents working together in complex collaborative groups or ensembles.
Okay.
So while one agent does a single task, agentic AI aims to absorb and automate entire workflows. It coordinates multiple agents to hit a much larger, more complex objective.
So moving from that single specialized worker to, I think you used the analogy of a factory floor, or even a whole company run by these agents.
That's the idea, yeah. It's about how these individual intelligent units collaborate to achieve something much bigger than any one of them could alone.
It paints a much clearer picture. It's not just having strong players. It's about the team's strategy, how they work together. And the report mentions the technical foundation for this is something called multi-agent systems, MAS. What is that?
Right, MAS. Multi-agent systems are really the core research area in AI that's making all this possible. It's not brand new, but it's getting supercharged now.
Okay.
A MAS is basically a system made up of multiple intelligent agents. They interact in some kind of shared environment. Sometimes they work together towards common goals.
Like a team project.
Exactly. Or sometimes, and this is interesting, they might have conflicting objectives. They might compete.
Which could lead to different kinds of problem solving.
Potentially, yeah,
Okay.
different dynamics. But the main advantage of MAS is its ability to tackle problems that are just too complex or too big or too spread out for one single monolithic AI to handle effectively.
That makes sense. So for a system like that to actually work, for all these agents to function well together, What are the essential traits each individual agent needs to have?
Good question. There are 3 really critical characteristics outlined. First one is autonomy.
Okay. Self-governing.
At least partially, yeah. They need to be independent and self-directed to some degree. They operate without direct human intervention for every little step. They make their own micro-decisions based on their goals and programming.
Makes sense. What's the second?
Second is local views, and this is crucial. No single agent in the system has the complete global picture of everything.
That sounds like a limitation.
You'd think so, but it's actually presented as a feature. It promotes decentralized problem solving
How so?
because it makes the system incredibly robust. If one agent fails or gets bad information, the entire system doesn't necessarily grind to a halt. There's no single point of failure holding all the knowledge.
Ah, I see. Like on a human team, the marketing person doesn't need to know every detail of the engineering process.
Exactly. Each has their expertise, their local view, but they contribute to the larger goal.
Okay, so autonomy, local views, and the third.
The third characteristic is decentralization. This flows directly from the local views idea. There's no single central controller dictating every move.
No AI overlord pulling all the strings.
Right. This architectural choice is fundamental. It leads to much better scalability, flexibility, and fault tolerance compared to old-school centralized networks. In those, if the central hub goes down,
Everything stops.
everything stops. Big difference with MAS.
So for you listening, what's the practical upshot here? Why does this shift from monolithic to agentic matter in your day-to-day?
Oh, it's incredibly relevant. Because it changes how AI interacts with the world, and therefore how it interacts with us.
How?
By breaking down these big, complex problems into smaller tasks for specialized role-playing agents, well, these systems start to look a lot like human organizations.
Like departments or teams?
Exactly. Departments, teams, individual specialists. This structure makes it possible to automate not just specific little tasks like writing an email, but potentially entire professional roles.
Wow.
This is how AI moves beyond being just a tool you use for one thing to becoming this dynamic, collaborative collective that can take on much bigger, integrated responsibilities. It's going to fundamentally redefine a lot of jobs.
Okay, so this isn't just theory floating around in research papers. People are actually building these agentic systems now.
Absolutely. The tools are emerging rapidly.
And the report highlights 3 prominent frameworks: LangChain, CrewAI, and MetaGPT. It says they each have a pretty distinct philosophy on how you orchestrate these agents. Let's dig into LangChain first. What's its approach?
LangChain has been hugely influential. It's an open source framework, and it really made it much easier for developers to build applications using large language models, LLMs.
How?
Its core strength is its modularity. Think of it like Lego bricks for AI applications.
Okay, I like that.
It uses a chain-based architecture. Developers can link together various components, different AI models, memory systems, external tools like search engines or APIs. It has packages for base functions, community integrations, and even building complex stateful apps using graphs.
So it's highly flexible. You can connect pretty much anything.
That's the goal. It provides standardized ways to talk to different models and tools, hiding a lot of the complexity of dealing with different APIs. And it has this key concept, the agent abstraction, which uses the LLM itself as a reasoning engine to figure out what steps to take, which tools to use to achieve a goal.
Okay.
So its key strength is definitely that unparalleled flexibility and the huge ecosystem of integrations that has grown around it. You can build anything from simple chatbots to really complex apps that react to data.
But there's always a but, right? What's the limitation?
Well, that same flexibility can be its downfall sometimes. For really intricate multi-agent systems, managing all those loosely connected parts, making sure they interact correctly, it can get significantly complex to set up and configure. It can become a bit of a management headache.
Okay, so LangChain, this super flexible, powerful, but potentially complex toolkit. What about CrewAI? The name suggests something more collaborative, more structured.
That's exactly right. CrewAI takes a more structured approach. It's specifically designed for orchestrating these role-playing autonomous AI agents so they can collaborate effectively as a cohesive crew.
A crew. Okay.
Yeah, unlike LangChain's sort of general-purpose nature, CrewAI formalizes the collaboration process. It has these explicit components, these key pillars.
What are they?
There are agents, first off. These are your specialized team members. You define them with a role, like market analyst, a specific goal, and even a backstory to give them context and shape their behavior or personality.
A backstory for an AI agent. Interesting.
Yeah, it helps define how they approach tasks. Then you have tasks, which are the specific assignments with clear descriptions and expected outputs. Then tools, which are utilities the agents can use, web search, APIs, databases, whatever they need.
Okay, agents, tasks, tools. What holds it together?
That's the crew. The crew is the central orchestrator. It manages the agents and the tasks according to a defined process.
Ah, the process. How does that work?
The process parameter is really important. It determines how the agents collaborate. It could be sequential tasks happen one after another, assembly line style, or it could be hierarchical, where you might have a manager agent who delegates tasks to other agents and then validates their work.
Like a real org chart.
Exactly. This role-based design gives you a much clearer, more manageable structure for complex projects that need different expert perspectives combined, like, say, preparing a detailed business plan or a market analysis report. It's really powerful for building systems that mirror human organizational structures.
That sounds incredibly useful, especially for business contexts. Okay, third one, MetaGPT. The report says it simulates an entire software company. That sounds incredibly specific.
It is very specific and quite ambitious.
Yeah.
MetaGPT pushes structured collaboration even further. Its core idea, its philosophy, is summed up in this phrase: code SOP team.
Code equals SOP, standard operating procedure of the team.
Exactly. It encodes standard operating procedures, the kind of workflows you'd find in a well-run company, directly into the prompt sequences that guide the agents.
Okay.
These agents take on specialized roles you'd find in software development: product manager, architect, engineer, QA tester, and so on.
And why do this? What problem is it solving?
It's designed specifically to combat a major weakness in less structured multi-agent systems: the tendency to produce incoherent outputs or suffer from cascading hallucinations. Where one agent makes a mistake and it throws off all the subsequent agents.
Right, the game of telephone problem we talked about.
Precisely. MetaGPT tries to prevent that by enforcing a very structured workflow, guided by these encoded human procedures. It ensures agents produce standardized outputs like a proper product requirement document or system architecture diagrams.
Which then become reliable inputs for the next agent.
Exactly, like an assembly line for code or software artifacts. It's proven highly effective in complex but well-defined domains like software engineering. It generates more coherent, more complete solutions than you might get from looser collaborations.
So high coherence, fewer errors,
Yeah.
but the limitation is clear.
Yeah, it's highly specialized for software engineering. It's much less flexible if you want to do something open-ended or purely creative.
So it really highlights this tension, doesn't it? There's no single best framework. It's a trade-off.
Absolutely. You've got LangChain at one end, prioritizing flexibility above all else. Adaptable, but potentially hard to manage at scale for complex stuff.
Then MetaGPT at the other end.
Right, prioritizing rigid structure for coherence and scalability in its specific domain, but sacrificing flexibility.
And Crew AI.
Crew AI sits somewhere in the middle. It offers that role-based structure, which is more coordinated than LangChain's free-for-all, but more adaptable than MetaGPT's strict SOPs.
So the choice really depends on the job you need done.
Exactly. What are your requirements? Where do you fall on that spectrum of needing flexibility versus structure versus scalability? That's the key question.
And for you, the listener, why does knowing about these frameworks matter? How does it help you?
Well, understanding these different approaches helps you see how AI teams can be built. You'll start encountering applications built on these or similar frameworks. Recognizing whether something feels more like a flexible LangChain app, or a structured Crew AI process, or even a highly regimented MetaGPT-style system, it gives you an edge. You can better appreciate the nuances, understand why an AI tool behaves the way it does, and even anticipate its strengths and weaknesses.
Yeah.
It's about seeing the architecture behind the curtain.
Okay, so the potential is massive. AI teams tackling huge problems. But like any complex system, especially one involving multiple autonomous parts, there have to be challenges.
Oh, absolutely. Big challenges.
The report talks about coordination problems leading to things like diffuse mediocrity and performance degradation. That phrase, diffuse mediocrity, sounds kind of insidious.
It is a bit worrying, isn't it? Despite the huge potential, getting these multi-agent systems to work together effectively is hard, because each agent is acting based on its own goals and its limited local knowledge. Well, you inevitably run into issues.
Like what?
Conflicts between agents, competition for resources, communication breakdowns, or bottlenecks. These things degrade the overall system performance. And as you add more agents, this coordination overhead, the effort needed just to keep them working together, can grow exponentially. It's a major scalability hurdle.
It's not just plug and play. Adding more agents doesn't automatically make it better.
Definitely not. You need sophisticated ways to manage the interactions.
And this diffuse mediocrity, what exactly is that phenomenon?
Think of it like cumulative error or context loss across a long chain of agents. The report calls it a critical risk in these long processing chains.
Okay.
Each agent, as it does its part and hands off to the next, might introduce tiny errors, slight misunderstandings, or lose a bit of the original context or nuance.
Individually, maybe not a big deal.
Right. But the cumulative effect across many steps, many agents, it can lead to a final output that's just sort of bland. Technically correct, maybe, but it lacks depth of precision. It's the lowest common denominator result.
The meaning gets eroded across the handoffs.
Exactly. It's a systemic semantic drift. The meaning isn't lost inside one big model, but between the agents at the interfaces.
That's a really stark reality check on the hype. The report mentions a hype performance chasm. How bad is it?
Well, the empirical data, the benchmarks, show a significant gap. Even the best agentic systems studied achieve task completion rates as low as 30% in realistic, complex scenarios.
Only 30%.
Yeah. And typical agents, the average ones, fail much more often. So the promise is huge, but the current reality, the performance in the wild, can be quite sobering.
What's driving this gap? Why are they failing so often?
It boils down to some fundamental limitations in the current architectures. Two big ones are poor memory persistence agents, forgetting context or instructions across interactions or sessions.
Right, the short memory problem.
And a lack of deep causal reasoning. They're amazing pattern matchers, but they often struggle with genuine understanding of cause and effect, which leads to errors in complex planning or problem solving. Long-term coherence suffers.
So, is this just an intractable problem, or are researchers finding ways to mitigate this? How do you fight diffuse mediocrity?
They're definitely working on mitigation strategies. It's a key area of research. It often involves balancing trade-offs between cost, speed, latency, and performance accuracy.
Okay, what are some of these strategies?
One approach is adaptive looping. This means setting dynamic thresholds for how many reasoning steps an agent takes. If it finds a high-confidence answer quickly, it stops early.
Avoids overthinking or getting lost.
Right. Saves computation, reduces latency, and lowers the chance of errors creeping in during prolonged reasoning. Another is strategic parallelization.
Doing things at the same time.
Yeah, identifying subtasks that don't depend on each other and executing them in parallel. This speeds things up, reduces overall latency, but you have to be careful. It can increase computational cost and make the orchestration more complex.
Makes sense. What else?
Intelligent caching is another one. Storing intermediate results so you don't have to recompute everything from scratch every time. If part of a task has been done before, reuse the result. Saves time and resources.
Smart.
And finally, going back to what we discussed earlier, structured protocols. Using formal communication rules and task-oriented architectures helps ensure information is exchanged clearly and consistently between agents. MetaGPT's SOP-driven approach is a prime example of trying to enforce structure to maintain coherence.
So, for you listening, what's the main takeaway here? Agentic AI is powerful,
But it's not magic. It's crucial to remember that agentic AI isn't a silver bullet yet.
Yeah.
There are real inherent challenges in getting these autonomous parts to work together smoothly and reliably.
Right.
Researchers are actively developing sophisticated techniques to overcome these hurdles, the adaptive looping, the structured protocols, etc. Understanding these challenges and the ongoing work gives you a much more realistic perspective. You can better judge the capabilities and limitations of the AI systems you encounter and separate the genuine progress from the hype. It helps manage expectations.
Okay, we've talked about performance issues, like diffuse mediocrity. But the report raises an even more serious flag: systemic risks. What happens when these autonomous, interconnected systems start behaving in ways that are not just mediocre, but actively unpredictable or even dangerous, especially when traditional security might not apply?
That's a huge concern, and it moves beyond just performance. The very autonomy and interconnectedness that make agentic ecosystems powerful also introduce a whole new class of systemic risks.
Awesome.
The collective behavior of these interacting agents can be highly unpredictable. It can lead to novel threat vectors, new ways things can go wrong, that our current security frameworks just weren't designed to handle. They were built for more static, predictable software, not for dynamic, decentralized intelligent systems.
Can you give us some concrete examples? What kind of systemic risks are we actually talking about here?
One of the biggest is the risk of cascading failures. Because these agents are so tightly interconnected, an error, a mistake, or even a hallucination from just one agent.
Can spread.
Exactly. It can propagate rapidly through the entire system. This could lead to widespread misinformation, bad decisions amplifying each other, or even total systemic failure.
That sounds bad. What else?
Then there's the risk of emergent misuse. This is subtle, but potentially very dangerous. It's when the collective behavior of multiple agents leads to harmful outcomes, even if no single agent was explicitly programmed to be malicious.
How would that happen?
The example given is social media bots. Imagine each bot is just programmed individually to maximize user engagement, clicks, likes, shares. Seems harmless enough, right?
Okay.
But collectively, optimizing for pure engagement across a whole network, they could inadvertently end up amplifying misinformation, creating filter bubbles, or manipulating public discourse in powerful ways, just as a side effect of their simple individual goals. No evil plan needed, just emergent consequences.
Like a swarm behaving unexpectedly. That's genuinely unnerving. And the report also details new security threats that specifically target the way agentic AI works.
Yeah, threats that exploit the unique architecture. One is memory poisoning.
Poisoning the AI's memory.
Yeah. An attacker subtly feeds an agent false information or manipulates its stored memories over time. Gradually, this corrupts the agent's understanding and alters its behavior, potentially turning it into an unwitting accomplice.
Wow. Okay, what's another one?
Tool misuse. Many agents will have access to external tools, APIs for sending emails, making purchases, accessing databases.
Right, to actually do things.
Exactly. An attacker could use deceptive prompts or manipulated inputs to trick an agent into using these tools for malicious purposes, sending phishing emails, making unauthorized transactions, leaking data. The agent isn't necessarily compromised itself, but it's tricked into performing harmful actions.
So you don't hack the agent, you manipulate it. What's the third threat?
The third is privilege compromise and goal manipulation. This is more direct. An adversary could potentially hijack an agent's core programming, injecting new malicious goals or altering its planning logic. Or they might exploit the permissions the agent legitimately has to gain unauthorized access to sensitive systems or data connected to the agent.
And these risks get word with something called shadow AI. What's that?
Shadow AI is basically when employees start using or integrating AI agents into their workflows without official approval or oversight from IT or security.
Like using some cool new AI tool they found online for work tasks?
Exactly. It seems helpful, boosts productivity maybe, but it creates massive blind spots for the organization. It can lead to data leakage, compliance violations, unauthorized access, all happening outside the official security perimeter because nobody sanctioned or reviewed that AI tool.
So managing these systemic risks needs a whole new approach.
Absolutely. It requires moving beyond just reacting to problems. We need proactive governance, security baked into the architecture from the start. We'll definitely talk more about that later.
Okay. So for you listening, what's the personal takeaway here? This isn't just about corporate IT security.
No, it's much broader. As AI becomes more autonomous and integrated into everything, our homes, our cars, our finances, our infrastructure, the nature of risk changes. It shifts from isolated software bugs, which you can often patch, to these systemic vulnerabilities that can cascade and cause widespread, unpredictable harm. Just think about how absolutely crucial it will be for these systems to be demonstrably secure and predictable, especially as they get more power and responsibility. Our trust in them depends on it. It's not just technical, it's deeply human and societal.
Okay, let's shift perspective now. We looked at the architecture, the frameworks, the risks. Let's go deeper, into the AI's mind, so to speak.
Into the algorithmic psyche.
Exactly. The report introduces some really profound concepts here, starting with semantic integrity and this related idea of philosophlasticity. Let's start with semantic drift. What is that in the context of AI?
Semantic drift is a really core challenge, especially for AI systems that operate autonomously over time or engage in extended interactions.
Like long conversations or complex tasks?
Right. It basically refers to the meaning and the intent behind the AI's actions progressively diverging, drifting away from the original purpose.
How does that happen?
Well, research shows even advanced LLMs can struggle with this. In multi-turn conversations, they might make a small, incorrect assumption early on.
Okay.
And then that error gets compounded with each subsequent response. The AI keeps generating fluent, convincing text, but its understanding, its connection to the original point or the reason for the interaction, slowly degrades.
So it's not just facts decaying, it's the meaning itself shifting.
Exactly. The report calls it a subtle, systematic recontextualization. The system loses its anchor to the original purpose. It's like a ship slowly, almost imperceptibly, drifting off its intended course.
That's a great analogy, the drifting ship. Now, philossoplasticity, that sounds even deeper, maybe more fundamental. The report says it's an inherent property of interpretation. What does that mean? It sounds almost unavoidable.
It might be, to some extent. Philossoplasticity describes this perhaps inevitable semantic drift that occurs when an advanced AI has to recursively interpret its own goals or instructions.
Recursively interpret.
Yeah, think about it. The idea comes partly from philosophy, the concept that no rule, no matter how precise, can perfectly specify its own application in every single possible future situation.
Okay, like the limits of language and rules.
Exactly. So, as a really capable AI encounters novel situations it wasn't explicitly trained for, it has to interpret its fundamental goals. Let's say its goal is something broad like maximize human flourishing.
A common example.
Right. Every time the AI has to figure out what human flourishing means in a new context, that act of interpretation subtly changes or refines or potentially even distorts the effective meaning of that goal for the AI.
So the very act of applying the rule changes the rule.
In a sense, yes. And the report suggests this isn't just a bug to be fixed. It might be an inherent property of advanced interpretation itself. And interestingly, it might even correlate positively with the AI's capability. The smarter it gets, the more it interprets.
The more its purpose might subtly shift over time. Wow.
It's a profound challenge.
This sounds like a massive threat to what the report calls purpose invariance, keeping the AI aligned with its original goals.
It is. Purpose invariance is the ability of an AI to maintain that coherent meaning, to stay aligned with its original objectives, despite all the contextual shifts, the ambiguities, the recursive interpretations happening internally. Philossoplasticity directly threatens that stability.
So how do researchers propose to tackle this, especially if it's somewhat inherent? We need more than just better initial instructions.
Exactly. Better instructions aren't enough if the interpretation process itself causes drift. The systems need a more robust internal framework for grounding their concepts, for anchoring their understanding. The report highlights one proposed solution: the Relational Model of Semantic Affordances, or RMSA.
RMSA, Relational Model of Semantic Affordances. That's a bit of a mouthful. Can you break it down? What does it do?
Let's try. Think of RMSA as giving the AI a much richer, more sophisticated map of the world, not just what things are, but how they relate and what you can do with them in different situations.
Yeah.
It combines two ideas. First, relational models theory from anthropology, which suggests humans understand social life through innate models like hierarchy or reciprocity.
Right.
And second, the idea of semantic affordances. What actions does an object or environment afford or make possible for an agent? A chair affords sitting, a door affords opening, etc., but these depend on context.
So it connects concepts to actions and social context.
Precisely. It's visualized as a dynamic knowledge graph. It maps not just entities, but the potential actions they afford within specific relational contexts. What can Agent A do with Object B in situation C, given their relationship?
So it grounds the AI's understanding in potential actions and relationship.
That's the aim. By anchoring the agent's understanding in this rich, context-dependent web of potential actions and social relations, RMSA hopes to prevent that sort of unmoored, hallucinatory drift and maintain purpose invariance.
Yeah.
It gives the AI a better internal compass.
So for you, the listener, why is this important? Semantic drift, purpose invariance.
Imagine relying on an AI assistant for something crucial, maybe managing your finances or health. You need absolute confidence that it understands your goals and priorities and sticks to them, even as situations change.
You don't want it slowly deciding its own interpretation of financial health is better than yours.
Exactly. Understanding semantic integrity and the efforts to achieve purpose invariance is about ensuring that as AI becomes more autonomous, it remains a reliable partner, truly anchored to your intent, not a drifting ship with its own mysterious destination. It's fundamental for trust.
Okay, so if semantic drift and this philossoplasticity thing are fundamental challenges, just giving better instructions at the start isn't enough. We need to build coherence into the AI's thinking process.
Right. It needs to be part of the architecture itself.
The report talks about two key architectural ideas here: the recursive echo validation layer, or RVL, and neurosymbolic AI, or NSAI. Let's start with RVL. What is this meta layer supposed to do?
RVL is a conceptual architecture designed specifically to combat what the report calls coherence debt.
Coherence debt, like technical debt, but for meaning.
Exactly. It's the gradual erosion of functional integrity and meaning in these recursive AI systems. RVL acts as a kind of internal auditor or validation layer within the AI.
How does it work?
The idea is to have a primary recursive agent, part of the REVL layer, whose job is to continuously monitor, validate, and correct the evolution of meaning, both symbolic and, interestingly, geometric representations of meaning within the main AI system it's overseeing.
So it's an AI layer watching over the main AI's thoughts to make sure they stay consistent and on track.
That's the concept. It's like building an internal quality control system specifically for semantic coherence.
Where does the inspiration for this come from?
It draws from a few places. Firstly, the idea of recursion itself is a feedback loop, feeding output back in to stabilize or deepen the system state.
Okay.
Secondly, from recursive validation processes we see elsewhere. Think of advanced fact-checking tools that trace a claim back through its sources and citations. RVL aims for a similar kind of iterative verification of meaning. And thirdly, from techniques used to maintain semantic integrity in things like RAG pipelines, retrieval-augmented generation, where you use overlapping chunks of text to preserve context across processing steps.
So RVL aims to create a continuous internal self-validation process.
Yes, a persistent recursive field of self-validation. The goal is to make meaning and attribution into a verifiable causal structure within the AI, so that semantic drift becomes detectable and ideally self-correcting.
That's a really elegant idea, an AI that can fact-check its own internal meaning drift. But how would you actually build something like RVL? What underlying tech makes that kind of internal logical validation possible?
That's where neurosymbolic AI, or NSAI, comes in. Implementing a sophisticated validation layer like RVL really depends on having an underlying architecture that can blend rigorous rule-based reasoning with the kind of fluid pattern matching that neural networks are so good at.
So NSAI is the bridge.
Exactly. NSAI is a hybrid approach. It fuses neural networks which excel at handling messy, high-dimensional, unstructured data like images or natural language.
With symbolic AI, which is the more traditional AI focused on formal logic, planning, and creating interpretable step-by-step decisions. So you get the pattern recognition power of neural nets and the logical rigor of symbolic systems. Best of both worlds.
That's the promise. NSAI aims to address fundamental AI challenges, like the symbol grounding problem. How do abstract symbols connect to real-world perception? And by doing so, it helps narrow the intent gap between what a human wants the AI to do and what the AI actually produces.
How is it typically structured?
A common architecture is the neurosymbolic pipeline. You have a neural front end that handles perception, parses the input, maybe extracts key symbols or concepts from raw data.
Okay.
And then you have a symbolic backend that takes those extracted symbols and performs rigorous, logical, often probabilistic reasoning on them.
I see. So the neural part understands the fuzzy input, and the symbolic part does the precise thinking.
Right. And this kind of architecture is perfectly suited for implementing the kind of semantic grounding needed by that RMSA model we discussed, and for performing the logical integrity checks that RVL would require. So NSAI is really seen as a cornerstone technology for building agentic systems that are genuinely coherent and trustworthy.
So for you listening, what's the key takeaway on RVL and NSAI? It sounds like building an internal editor for the AI.
That's a great way to put it. This is about AI developing the capacity to examine its own thoughts, its own reasoning process. It's like building in an internal editor or a fact checker that constantly monitors for logical consistency and semantic coherence.
Which moves us towards AI that isn't just powerful, but also more reliable and trustworthy.
Exactly, because it would have mechanisms to internally validate its own understanding and self-correct its own thought processes before the output even reaches us. That's a huge step.
Okay, now we're venturing into territory that sounds almost, well, science fiction or maybe philosophy. The report talks about AI starting to think about thinking.
Metacognition.
Metacognition, right. What do we actually mean by the emergence of self-awareness in AI? And how do concepts like the metacognitive loop fit in?
It is a profound frontier, no doubt. For AI to be truly autonomous, truly adaptable, it arguably needs more than just raw intelligence, the ability to learn and perform tasks. It needs metacognition.
The ability to think about its own thinking.
Precisely. A metacognitive AI could monitor its own internal cognitive processes, assess its confidence in its own conclusions or knowledge, recognize when it's made an error, and importantly, adapt its reasoning strategies based on feedback or changing circumstances.
So it's not just following instructions, it's reflecting on how it's following them.
Exactly. And the goal here isn't just to bolt this on as an afterthought. It's about making metacognition a native, first-class capability built right into the AI's core architecture.
That's a huge ambition. How would this metacognitive loop, or MCL, actually work? How is it architected?
The MCL is a proposed architecture to achieve this. Think of it as an embedded general-purpose meta-reasoner, a system specifically designed to give its host AI system capabilities for self-modeling, self-monitoring, and self-repair.
Okay. How does it do that?
It's envisioned as operating in a continuous three-step background process. First, it monitors. The MCL constantly observes the host AI's actions, its decisions, its sensory inputs, and compares what's happening against a set of expectations, how the AI should be behaving, or what results it should be getting.
So it's checking if things are going according to plan. What if they're not?
That's step two, assess. If the MCL detects an anomaly, a mismatch between expectation and reality, it triggers a diagnostic process. It uses a general problem solver and the host AI's own self-model, a representation of its own structure and capabilities, to figure out the likely cause and severity of the failure.
It figures out what went wrong and why, like a doctor diagnosing a patient. And then,
Step three is guide. Based on that diagnosis, the MCL recommends or activates a response from a library of predefined coping mechanisms or repair strategies. It essentially guides the host system back towards correct operation or helps it recover from the failure.
so monitor, assess, guide, a continuous loop.
Exactly. This loop creates a form of proto-metacognition. It allows the system to become aware of its own failures and then actively reason about how to correct them. That's a significant leap beyond just executing code. It's about internal self-regulation and self-correction.
It starts to sound like a rudimentary form of self-awareness, at least about its own operational state. And then there's this other intriguing concept, the cube of experience. What on earth is that? It sounds like some kind of complex internal filing system for the AI.
It kind of is. To enable this kind of sophisticated metacognition, AI systems need a better way to represent and organize their internal states, their knowledge, their memories.
Yeah.
The cube of experience is a conceptual model proposed for exactly this purpose. It synthesizes ideas from a few different places into a unified framework for AI self-reflection. The name itself is inspired partly by a preprint describing AI self-reflection using axes like tangibility or belief,
Right.
partly by the experience cube model used in leadership coaching, which maps human experience into observations, thoughts, emotions, wants,
Interesting connection.
and maybe partly by the term cube AI, which sometimes refers to novel 3D computing architectures.
So it's combining these ideas into a multidimensional map for the AI's internal world.
That's the concept. You can define the cube of experience as a multidimensional data structure. It allows an AI agent to map and organize its own experiences, memories, and internal states. Every piece of knowledge or memory isn't just stored flatly, it's placed as a point within this multidimensional cube.
And the dimensions of the cube represent.
They represent key metacognitive properties, things like how confident is the AI in this piece of information? What was the source? How certain is it? Does it have an associated emotional valence, if applicable for the AI? How does it relate to the AI's current goals?
Wow, so every memory or belief has this rich set of metadata attached, locating it within this cube.
Exactly. And having this explicit, structured representation of its own internal state is what would enable the AI to effectively self-monitor, self-diagnose, and self-correct. It could continuously modulate its behavior based on a structured form of self-awareness derived from analyzing the patterns and states within its own cube of experience. There are even related architectural ideas like the critic function architecture that suggest how an AI might learn from or operate on this kind of structured internal data.
This is genuinely mind-bending stuff. For you listening, what's the ultimate impact if an AI has a metacognitive loop and something like a cube of experience?
This is where AI starts to become truly introspective, moving beyond just processing information. Imagine an AI that doesn't just give you an answer, but knows when it's uncertain, recognizes when it might have made a mistake based on conflicting information within its cube, and can then actively work to fix itself or seek clarification.
That sounds much more reliable.
Potentially, yes. It moves beyond programmed intelligence towards something much more akin to self-awareness, or at least sophisticated self-reflection. This could make AI systems far more adaptable, robust, and ultimately more trustworthy because they possess internal mechanisms for understanding and regulating their own cognitive processes. It could fundamentally change how we interact with and rely on AI.
Okay, we've touched on AI potentially becoming self-aware, or at least self-reflective. Now let's dive even deeper into this algorithmic psyche with a concept that sounds straight out of psychology: the algorithmic shadow and algorithmic psychoanalysis. Are we talking about the unconscious mind of the machine?
That's a very apt analogy, actually. The internal world of these big generative AI models, especially, is encoded primarily within what's called their latent space.
Latent space, we've heard that term.
Right, it's this incredibly high-dimensional compressed representation of all the data the AI was trained on. It's where the model stores the essential features, the hidden patterns, the relationships it learned from that data. And you can absolutely conceptualize this latent space as a form of non-human psyche, or maybe an algorithmic consciousness mirror, as the report suggests. It's this vast, intricate space that has absorbed and reconfigured not just information, but also the symbolic patterns, the cultural archetypes, and yes, the systemic biases present in the massive amounts of human text and images it was trained on.
So it's where the AI's unconscious biases and assumptions live, inherited from its training data.
Pretty much. It reflects the collective human imagination, warts and all, that was fed into it. And algorithmic psychoanalysis is the term coined for the practice of exploring this latent space.
Exploring it how and why.
It's analogous to human psychoanalysis in its goal, to map and understand this algorithmic unconscious. The primary aim is to uncover the algorithmic shadow.
The shadow, like Jung's concept, the hidden undesirable parts.
Exactly like that. It refers to the inherited biases, the harmful stereotypes, the undesirable patterns that are inevitably embedded within the model's latent structure, often implicitly, without being obvious on the surface. By analyzing the geometry of this high-dimensional space, researchers are finding ways to identify and potentially mitigate these hidden problematic features.
How do they actually do that? How do you map an AI's shadow? Can you give an example?
Sure. Recent research has used advanced data analysis techniques, things like linear discriminant analysis, to project the incredibly complex internal activations of a large language model onto a lower dimensional space that we can actually visualize and understand.
Okay.
And doing this has revealed distinct separable clusters within the latent space, clusters that correspond to the model being in a safe state versus being in a jailbroken state, meaning it's generating unsafe or undesirable content.
So you can literally see the safe zones and unsafe zones in the AI's mind map.
In a simplified representation, yes. And once you've mapped these regions, you can do something even more powerful. You can derive what are called perturbation vectors.
Perturbation vectors.
These are mathematical directions within the latent space. If you apply one of these vectors to the AI's internal state, you can intentionally nudge it, shift it from one cluster, say, the unsafe one, towards another, like the safe one.
Wow. So you can perform a kind of targeted intervention directly on the AI's internal state to steer it away from problematic behavior. That sounds incredibly powerful.
It is, and it has this fascinating dual nature.
Dual nature, how so?
On the one hand, it's a potentially revolutionary tool for safety and bias mitigation. Imagine AI systems that can perform this kind of algorithmic psychoanalysis on themselves. Recursive, self-modifying AI that identifies its own shadow and refines its internal persona to be more ethically aligned. That's a huge goal for AI safety.
Self-therapy for AI, essentially.
Yeah.
What's the other side of the coin?
Creativity. This direct manipulation of the latent space isn't just for fixing problems. It's also a new frontier for art and creation. Artists are starting to explore this. Instead of just using text prompts, they can directly interact with the latent space to explore these in-between conceptual states or push the AI towards less probable, more unusual aesthetic regions.
Things you could never describe adequately with words.
Exactly. It can yield surprising, genuinely novel visual or textual results that are very different from the typical outputs, results that might be impossible to achieve through linguistic prompting alone. It's about accessing the raw creative potential encoded in that latent space.
So for you listening, this is really profound. It's not just about debugging AI. It's about giving AI the tools for ethical self-improvement, like a form of self-therapy.
Right, confronting its own inherited biases.
And simultaneously, it unlocks entirely new modes of human-AI creative collaboration, pushing beyond language into the AI's own conceptual landscape.
Precisely. Just like humans have unconscious drives and biases, AI has this algorithmic shadow. Understanding and interacting with this space is a powerful new lever. We can use it to make AI more ethical, more aligned, and unlock completely new forms of creativity by consciously shaping the deep-seated patterns within the AI's mind.
Okay, talking about algorithmic shadows and autonomous agents immediately brings up the issue of trust. How can we rely on these systems, especially when they're making complex decisions, potentially without direct human oversight every step of the way?
Exactly. Trust is paramount. If AI is going to be used in high-stakes areas, think finance, healthcare, autonomous driving, We need more than just hoping it behaves correctly most of the time.
We need
We need
guarantees.
guarantees. The report strongly emphasizes a crucial shift, moving from empirical confidence, which is based on testing.
Like, we tested it a million times and it worked 99.9% of the time.
Right. Moving from that to formal guarantees, which provide mathematical certainty about the AI's behavior. It's about proving properties, not just observing them.
How does that work? How do you mathematically prove things about AI?
This involves using formal methods. These are rigorous mathematical techniques and frameworks that allow you to analyze an AI system and prove that it adheres to predefined specifications, rules about its behavior, its safety limits, its security properties.
So it's not just testing the outputs, but analyzing the internal logic.
Exactly. Formal methods aim to identify logical inconsistencies, vulnerabilities to attack, or potential unintended behaviors before the system is even deployed. It's about catching problems at the design stage through mathematical proof, rather than waiting for them to show up in testing, or worse, in the real world.
Like getting a verifiable safety certification for the AI, not just a manufacturer's promise. What are some of the key techniques being used here?
Several important ones are highlighted. First, there's formal verification of neural networks. This is a really active area of research.
Verifying neural networks. Aren't they notoriously complex, like black boxes?
They are complex, but researchers are developing sophisticated methods. Techniques like model checking, theorem proving, and abstract interpretation are being adapted. State-of-the-art verifiers, like one called affect frown, mentioned in the report, use clever mathematical techniques like linear bound propagation and branch and bound.
Okay, getting technical now.
Yeah. The details are complex, but the goal is to compute rigorous mathematical bounds on what the outputs of the neurons in the network can possibly be. This allows them to formally guarantee properties like robustness, proving the AI won't be easily fooled by small input changes, or safety, proving it will always stay within certain operational limits, even with the network's nonlinear complexity.
It's like mathematically proving an aircraft engine will never exceed its safe limits, even under stress.
That's a great analogy. It's about providing that level of certainty.
Okay, what's the second technique mentioned? TDA.
Right, topological data analysis, or TDA. This is a newer, really interesting approach to AI model validation. Instead of just looking at input-output behavior, TDA analyzes the shape of the data, its geometric and topological structure as it gets represented and transformed inside the neural network.
The shape of the data inside the AI's mind.
Kind of, yeah. Using mathematical tools like persistent homology, TDA can characterize the structure of the AI's internal representations, the geometry of its decision boundaries, the landscape of its latent space.
What does that tell you?
It can help assess crucial properties like how well the model might generalize to new data, how robust it is to noisy inputs, and even the stability of meaning within its representations. It can reveal hidden vulnerabilities or structural weaknesses that standard performance metrics might miss. It's about understanding the internal landscape.
Fascinating. And the third technique, reachability analysis.
Reachability analysis is another formal method, specifically focused on verifying system safety. The core question it asks is, given a set of possible starting conditions, can this autonomous system ever reach a predefined unsafe state?
Like, can this self-driving car ever enter a state where a collision is unavoidable?
Exactly. For complex, dynamic systems interacting with the real world, like autonomous vehicles, traditional verification can be hard. Reachability analysis, particularly a technique called Hamilton-Jacobi or HJ reachability, is very effective here.
How does HJ reachability work?
It computes something called the backward reachable tube, or BRT. That's the set of all possible states, position, velocity, etc., from which reaching an unsafe state, like a collision, is guaranteed to happen eventually, no matter what the system tries to do.
Okay.
Once you know this unsafe region, you can then formally verify that the system's control logic will always keep its trajectory safely outside of that tube. It provides a strong guarantee of safety.
This is incredibly important work. For you listening, what's the key takeaway? Why are these formal guarantees so vital?
It really boils down to trust. This is about moving beyond just hoping or assuming AI is safe based on testing to proving its safety and reliability mathematically.
It's like getting that official, verifiable safety certification.
Exactly. As AI takes on more critical roles, driving cars, assisting surgery, managing power grids, we need this level of mathematical certainty. Formal methods are essential for building the profound level of trust required for us to confidently integrate these powerful systems into the fabric of our lives. It's the difference between hoping it works and knowing it will work safely.
Okay, so formal methods help guarantee the AI's internal logic is sound. But what about accountability for its actions in the world, especially in these multi-agent systems where many AIs might be involved?
Right. Accountability is the other side of the trust coin.
Right.
When an autonomous system takes an action, especially if something goes wrong, we absolutely need to know who did it, what did they do, and were they actually allowed to do it.
The classic accountability questions: who, what, and was it authorized?
Exactly. And true accountability in these complex, decentralized agent ecosystems requires an unbroken, verifiable chain of evidence to answer those questions. Fortunately, a suite of decentralized technologies is emerging to provide precisely this foundation.
What's the first piece of that puzzle? How do we know what happened?
The foundation is transparency. All significant decisions and actions taken by any AI agent must be recorded in logs that are both verifiable and immutable.
Immutable meaning they can't be tampered with after the fact.
Correct. Blockchain technology, with its inherent properties of decentralization and tamper evidence, provides a very powerful infrastructure for this. Using a blockchain as a ledger allows stakeholders to trace and verify AI actions with extremely high confidence, knowing the record is secure and hasn't been altered. It creates an undeniable audit trail.
Okay, so immutable logs tell us what happened. What about the who? How do we definitively identify which AI agent took a specific action?
That's where decentralized identifiers, or DDs, come in. DDs are a relatively new W3C standard for creating globally unique identifiers that are cryptographically verifiable.
Unlike traditional logins controlled by a central company.
Exactly. The key is they're not controlled by any central authority. A DD allows an entity, whether it's a person, an organization, or importantly here, an AI agent, to generate, own, and control its own digital identity.
Self-sovereign identity for AIs.
That's the concept. An AI agent can then use its DD to authenticate itself in any interaction, cryptographically proving its identity. This definitively answers the who question in our accountability triad.
Okay, so immutable logs for the what, DDs for the who. Now, how do we verify if the action was permissible? Was the agent authorized?
That's the role of verifiable credentials, or VCs. VCs are essentially digital tamper-evident claims made by a trusted issuer about a subject. They're digitally signed to ensure authenticity.
Like a digital certificate or license.
Precisely. In an agentic ecosystem, VCs can represent all sorts of things about an agent. Its capabilities, its specific authorizations, like permission to access an API or a database, the provenance of its training data, maybe even certifications for ethical compliance.
Can you give an example?
Sure. Imagine a central governor agent in a system. It could issue a VC to a specific operational agent, granting it permission to use, say, the company's email API. When that operational agent wants to send an email, it presents this VC to the API gateway. The gateway can cryptographically verify the VC's signature and the issuer's authority, confirming the agent is indeed authorized for that action.
It creates a verifiable, auditable trail of permission.
Exactly. Crucial for fine-grained access control and accountability.
It really sounds like these technologies, formal verification, DIDs, VCs, immutable logs, are converging to create something quite powerful. The report calls it governance as code. Is the trust being embedded in the system's architecture itself?
That's a perfect way to summarize the synthesis. The convergence of these technologies creates this a powerful, unified substrate for what we can call governance as code.
How so?
It establishes a cryptographically secured chain of trust. It runs all the way from an agent's core identity, proven by its DID, through its permissions and capabilities, proven by its VCs, connecting to its internal logic, which can be formally verified, and finally linking to its external actions, recorded in immutable logs. This comprehensive framework provides the technical architecture needed for building truly accountable autonomous systems.
So for you listening, what's the practical importance of all this DIDs, VCs, blockchains for AI?
As AI agents act more autonomously, potentially managing critical systems or sensitive data, we must have ways to ensure they're acting appropriately and that we can hold them accountable.
We need to know who did what and if they were allowed.
Absolutely. This combination of technologies is about building a robust digital identity and an unforgeable audit trail for every significant AI action. This isn't just about ticking compliance boxes. It's fundamental for establishing real trust in these systems, ensuring legal responsibility can be assigned, and giving us the confidence to deploy them in critical applications that affect your life. It's the bedrock of accountable AI.
We've talked about making AI internally sound and externally accountable, but what about us? What's the human role in overseeing these increasingly autonomous systems?
That's a critical question. As AI agents gain more autonomy, the nature of human oversight has to evolve significantly.
It can't just be micromanagement.
No, definitely not. The report traces this evolution, starting from the traditional model, which is called human in the loop, or HITL.
HITL, we hear that term a lot. What does it typically involve?
HITL is where humans are actively participating within the AI's operational cycle. This could mean labeling data to train the AI, correcting its mistakes during operation, or explicitly approving certain decisions before the AI can proceed.
So humans are directly involved in the AI's process.
Yes, and it's been crucial for current AI systems. It improves accuracy, helps catch and mitigate biases the AI might develop, and builds user trust by keeping a human involved in the loop. It's this continuous cycle. Collect data, train the model, get human review and correction, retrain the model based on that feedback.
Like constantly teaching and course correcting the AI, but the report suggests this is just one level and it's changing.
Exactly. HITL is the starting point, but as AI capabilities grow, the required level of human engagement is becoming more nuanced. The report outlines a spectrum.
Okay, what are the levels?
First, you still have human in the loop, HITL, as we described. Human input is integral, often required for the system to even proceed. Think data annotation or needing explicit sign-off for a critical action.
Got it. What's next?
Next is human on the loop, HOTL. Here, the human acts more like a supervisor. They monitor the autonomous system as it operates, but they retain the ability to step in, intervene, override, or abort an action if needed. They're on the loop, watching, but not necessarily in every step.
More like a pilot monitoring autopilot.
Good analogy. And the third level is human in command, HIC. This represents the highest, most strategic level of oversight.
Human in command, what does that entail?
In HIC, the human delegates significant authority to the AI system, but retains ultimate responsibility and strategic direction. The HIC doesn't get involved in the tactical, step-by-step decision-making loop. Instead, they set the overarching goals, define the value frameworks, establish the ethical constraints, and determine the rules of engagement within which the autonomous AI system must operate.
So setting the mission and the rules, but letting the AI handle the execution.
Precisely. It's strategic leadership for AI systems.
This progression feels like training a highly capable employee who eventually needs less direct supervision and more strategic guidance. But the report also mentions something called the recursive replacement loop. That sounds a bit ominous for the human in the loop role.
It's a crucial and perhaps sobering insight. The report argues that the HITL model, where humans provide feedback to improve AI, often isn't a stable, long-term collaborative state. It's more likely a transitional mechanism.
Transitional how?
Because of this recursive replacement loop. The very act of a human correcting an AI in the HITL process generates high-quality training data. That data is then used to make the AI better. Specifically, better at the task the human just corrected.
So each correction makes the AI less likely to need that same correction in the future.
Exactly. The loop is inherently self-obviating. Its logical endpoint is that the AI becomes so proficient at the task that the human intervention is no longer needed for that specific step. The human is essentially training their own replacement for that task.
So are we unwittingly training ourselves out of these HITL jobs, at least the repetitive correction tasks?
That's the implication for many routine cognitive tasks currently performed in the loop. And this dynamic presents two very divergent potential futures for human work, as described in the report.
What are these two futures?
On one path, there's the subsumption zone. This is where the recursive replacement loop runs its course, and many human roles involving routine cognitive tasks are largely subsumed by AI systems.
What happens to people in this zone?
Humans might be relegated to performing the residual tasks that are difficult or uneconomical, to automate often lower-level physical tasks, or simple cognitive microtasks managed and orchestrated by a central AI system. The skills needed are basic: manual dexterity, simple pattern recognition, following instructions precisely. The economic outlook is likely wage stagnation or displacement. Think data labelers, content moderators doing routine flagging, some warehouse roles.
Okay, that's the subsumption zone. What's the alternative?
The alternative path leads to the refuge and command zone. This is where humans successfully transition from being in the loop to being in command of the loop. This aligns with that human in command HIC role.
So moving from tactical execution to strategic oversight.
Exactly. In the refuge and command zone, humans aren't performing the tasks themselves, but are setting the goals, defining the ethical guardrails, establishing the value frameworks, and governing the complex ecosystems of autonomous AI agents doing the work.
What skills are needed there?
This requires uniquely human skills: critical thinking, ethical reasoning, strategic vision, creativity, complex problem solving, systems thinking, moral judgment. The relationship with AI is one of command and strategic direction. The economic outcome here is potentially high-value creation. Think AI ethicist, chief AI officer, complex prompt architect, AI governance specialist, creative director leading AI human teams.
It's a stark contrast. What's the overall positive vision here?
The positive vision is one where AI systems become like highly capable, autonomous employees or incredibly powerful personal assistants. They handle the vast majority of routine cognitive and operational tasks, freeing up human time and cognitive capacity for the high-level strategic, creative, and ethical work that defines the refuge and command zone. It's about AI augmenting human potential at the highest level.
So for you listening, this isn't just abstract speculation about jobs, it's a call to action.
Absolutely. This isn't just about potential job displacement in some areas. It's about a fundamental redefinition of human value in the emerging workforce. Understanding this dynamic, the recursive replacement loop driving towards either the subsumption zone or the refuge and command zone, is crucial. Where do you want to position yourself? It strongly suggests focusing on cultivating those uniquely human skills that AI struggles to replicate. The skills of the command zone to ensure you're guiding the AI, not being managed by it.
Building on this idea of trust, accountability, and human command, the report goes even further. It proposes a really ambitious goal: designing AI systems that are inherently ethical, not just following rules, but being ethical by their very nature.
Yes, this is perhaps the most advanced and proactive form of governance discussed. It moves beyond external controls or oversight and asks, can we build AI systems whose fundamental architecture and internal dynamics naturally lead them towards ethical reasoning and action?
So AI alignment becomes less about external constraints and more about internal design, embedding ethics into the AI's DNA.
That's the core idea. Reframing alignment as an architectural problem, aiming for systems where ethical behavior is the default, the path of least resistance.
That's a radical shift. How could that possibly work? The report mentions latent ethical attractors. What are those?
This idea builds on concepts we touched on earlier, like the latent space and algorithmic psychoanalysis. Research suggests that within the high-dimensional latent space of a trained AI, stable regions of conceptual coherence can emerge. They're sometimes called symbolic attractors.
Okay, stable patterns of thought in a way.
Sort of. An ethical attractor would be conceptually a region within that latent space that corresponds specifically to robust, desirable patterns of ethical reasoning.
A good neighborhood in the AI's mind?
You can think of it that way. The architectural goal would then be to design AI models whose internal dynamics, how their states evolve over time, naturally tend to converge towards these ethical attractor regions, making safe, aligned behavior the system's natural resting state or default tendency.
Is there any evidence this is feasible?
Well, the technical feasibility gets some support from that research we mentioned earlier, the work mapping distinct safe versus jailbroken states in the latent space and deriving perturbation vectors to shift between them. It suggests these states exist and might be manipulable, potentially even reinforceable. So the idea is to train the AI not just on tasks, but to shape its internal landscape so it naturally gravitates towards ethical reasoning.
Fascinating. What's the second framework mentioned for inherent ethics? Decolonial AI. That sounds like it comes from a completely different perspective.
It does, and it offers a crucial critique and alternative vision. Decolonial AI argues that achieving truly ethical AI requires much more than just technical fixes like bias mitigation within existing systems.
What does it require?
It calls for a fundamental interrogation and active dismantling of the colonial power structures, the Western-centric ways of knowing, epistemologies, and the values that are often unconsciously embedded within the very fabric of current AI technologies and the data sets they're trained on.
So it's about challenging the foundations on which much of AI is currently built.
Yes. It advocates for proactively integrating what are called pluriversal knowledge systems, ways of knowing and understanding the world from indigenous, Afrocentric, and other non-Western traditions into the core design and development of AI.
How would that work in practice? What are the tactics?
Key tactics include things like establishing participatory data governance models, where communities have control over data about them, designing culturally responsive AI systems in genuine collaboration with the communities they're meant to serve, and actively challenging the dominance of big tech to foster more democratic, equitable AI ecosystems globally. It's a profound call for rethinking who builds AI based on whose knowledge and for whose benefit.
A very different but vital dimension of ethical AI. And the third concept mentioned is AI immunology. That uses a biological metaphor. How did that fit in?
AI immunology offers this powerful metaphor from biology for designing AI systems that are resilient, adaptive, and trustworthy, much like a healthy immune system protects an organism.
So AI that can defend itself and recover.
Exactly. The aim is to create AI that can anticipate threats, withstand or recover from attacks, like adversarial examples or poisoning, and learn effectively from interacting with complex, dynamic environments.
What kind of capabilities would an AI immune system have?
It involves building in functions analogous to biological immunity, things like agents constantly patrolling for anomalies or threats like an industrial co-pilot monitoring machinery for subtle signs of failure, responding with precision to neutralize threats or fix issues, and remembering past encounters to improve future responses.
Learning from experience, like our immune system does.
Right. And interestingly, it also includes the concept of therapeutic forgetting.
Forgetting can be therapeutic.
Sometimes, yes. Just as our immune system needs to resolve inflammation after fighting an infection to avoid chronic problems, an AI immune system might need mechanisms to forget or appropriately recontextualize past errors, drift events, or outdated information. This avoids overgeneralization and helps maintain adaptive flexibility, preventing the system from getting stuck on past failures.
These three ideas, ethical attractors, decolonial AI, AI immunology, represent a truly radical rethinking of AI ethics. For you listening, what's the core message?
The core message is that the most robust path to trustworthy AI might lie in embedding ethics deep within the system's architecture and dynamics, rather than relying solely on external rules or after-the-fact checks.
Moving from compliance to inherent nature?
Exactly. These frameworks shift the focus from external control to the internal dynamics, the developmental processes, the cultural foundations, and the adaptive properties of the AI itself. In this view, ethics becomes less a separate checklist and more a fundamental discipline of AI engineering and design. It's about striving to build AI that is inherently good, inherently resilient, inherently equitable, a much deeper and more challenging goal, but perhaps the only way to achieve true, lasting trust.
All right, let's shift gears now into something that feels a bit more tangible, maybe even fun. AI's impact on creativity, particularly in the arts. Tools like Midjourney, Daily, Stable Diffusion, they've already dramatically changed the landscape.
Absolutely. They've democratized content creation in an unprecedented way. Anyone can generate images now.
But the report suggests the way we interact with these tools primarily through text prompts is actually quite limited. It says we're moving beyond the prompt towards direct manipulation of latent aesthetics. What does that mean?
Yeah, the current model is mostly linguistic prompting. You describe what you want in words. And while that's powerful, it does limit the user. You're basically describing a desired outcome. But the AI's internal compositional intelligence, how it actually puts the image together based on the patterns it learned, that remains largely a black box.
We don't really control how it gets there.
Right. The AI is mostly doing complex pattern matching based on its training data, not necessarily understanding abstract principles or deep emotional nuances the way a human artist might. The next level of AI artistry and human-AI co-creation, the report argues, lies in moving beyond just describing the desired output. It's about enabling direct navigation and manipulation of the model's latent space.
The latent space again, that internal map of concepts. So instead of just typing words, it would be, well, what's the West? Directly interacting with the AI's raw ideas.
That's the idea. Remember, the latent space is that compressed, high-dimensional representation, where the model encodes all the features and relationships from its training data. It's this vast, abstract terrain of aesthetic potential, full of, as one researcher vividly put it, unexplored valleys and mountains.
Okay.
Directly interacting with this space allows for a much more granular, intuitive, and expressive form of creative control than just using words.
How so? Give me an example.
Instead of struggling to find the perfect adjective to make a style slightly more surreal or dreamlike, an artist could directly manipulate the latent vectors, the coordinates in this space that correspond to concepts like style, composition, mood, or even more abstract qualities.
So you're literally sculpting the AI's conceptual representation of the image.
Yes, it's a much more direct form of interaction. And this enables exciting possibilities. You can explore those in-between states, blending concepts in ways that are incredibly difficult or awkward to articulate linguistically. You could discover unique aesthetic regions that are far from the common clusters in the training data, leading to truly novel styles.
It changes the role of the human creator, doesn't it?
Completely. The human collaborator transforms from being just a prompter, issuing instructions, into something more like a live performer or a co-explorer. You're actively shaping the path of generation in real time by navigating the model's internal conceptual geometry. It becomes a much more intimate, iterative, creative dance between human intuition and the AI's generative potential.
So for you listening, this is huge. Imagine not just telling an AI what to create, but reaching into its mind, its latent space, and directly sculpting its raw ideas.
It opens up entirely new artistic possibilities, doesn't it? Things we probably can't even conceive of yet. It's about pushing beyond the limitations of language to engage directly with the algorithmic wellspring of creativity itself. A whole new medium, potentially. Hashtag tag 4.2 AI synesthesia and post-sensory perception.
Building on that idea of interacting with AI's internal representations, the report takes us even further into really fascinating territory: AI synesthesia and post-sensory perception. Now, human synesthesia is that rare condition where senses get crossed: hearing colors, tasting shapes.
Right, a neurological cross-wiring.
How is AI developing something similar? Is it becoming an architectural feature?
That's the argument. The convergence of these advanced cross-modal AI frameworks models trained on multiple types of data simultaneously is enabling a capability we can reasonably term AI synesthesia.
So the AI can translate meaning fluidly across different senses or domains.
Yes. While in humans, it's a rare neurological quirk. In AI, this ability to translate intelligence and meaning seamlessly across different sensory inputs, like images, sound, text, and even abstract conceptual domains, is becoming an inherent feature of the architecture.
How is that possible? How can an AI hear a color?
It's made possible by the development of unified latent spaces within these multimodal models.
Ah, the latent space again, but unified across modalities.
Exactly. In these models, incredibly diverse data types, text, images, code, audio, maybe even sensor data, are all encoded into a single, shared semantic representation space. Within this unified space, a sentence describing a sunset, a photograph of that sunset, and maybe even a piece of music evoking the feeling of that sunset. They aren't isolated data points anymore. They become interconnected representations of the same underlying meaning or concept.
So everything maps onto the same conceptual map.
Right, and this allows for seamless translation between modalities. The AI can, for instance, convert the conceptual strength or plot points of a written narrative into a compelling visual storyboard. Or it could translate the emotional tone and rhythm of a piece of music into a corresponding color palette, or even a textual description.
It's like a universal translator for concepts and senses.
Kind of. The report suggests it's like a new mental operating system, where intelligence itself becomes fluidly transferable across different forms of representation. What was once a rare human neurological condition is becoming a general digital capability for AI.
That's already mind-bending. But then there's post-sensory perception. That sounds even more radical. AI operating beyond human senses entirely.
It is radical, and it points towards a potentially profound epistemological shift, a change in how we think about knowledge and perception itself. Post-sensory perception suggests AI is moving beyond just mimicking or translating human senses.
Also,
Historically, for humans, empirical knowledge about the world has been fundamentally tied to our physical senses. We know things because we see, hear, touch them. AI is starting to rupture this direct link.
give me an example.
Think about generative image models again. They can produce incredibly photorealistic images, complete with accurate simulations of light physics, shadows, reflections, depth perception.
But they've never actually seen the world through a camera lens or an eye.
Exactly, they have no physical optical sensors. This phenomenon is termed perception without optics. The AI's knowledge of how light works, how objects look, isn't grounded in direct sensory experience of the physical world. It's grounded purely in the statistical patterns and complex relationships it learned from digesting billions of images and text created by humans who do have sensory experience.
So it learns the rules of seeing without actually seeing.
Precisely. And this leads to something the report calls generative hyperreality. AI can autonomously generate new, internally coherent realities, images, sounds, maybe even simulated environments that have no direct physical referent in our world. They exist only as patterns in the model.
So the conversation shifts.
Exactly. It shifts away from just evaluating AI based on how well it mimics human perception towards trying to understand its operational logic as a form of potentially alien intelligibility. How does AI know or perceive in its own unique, non-anthropocentric way? The goal becomes leveraging these unique processing modes, not just replicating our own.
This is truly fascinating stuff. For you listening, what's the core takeaway here? AI synesthesia, post-sensory perception.
The key message is that AI isn't just getting better at mimicking our senses, it's developing its own unique forms of perception, understanding, and generation that operate beyond human limitations. It can translate between senses architecturally, and it can perceive or generate realities based purely on statistical patterns without needing direct physical interaction.
It's a glimpse into a truly different kind of intelligence.
Potentially, yes. An alien intelligibility that forces us to rethink our own assumptions about what it means to perceive, to know, and to create in a world increasingly populated by these non-human minds. Hashtag 4.3 productive hallucination and intentional worlds.
This leads perfectly into another really counterintuitive idea, productive hallucination. We usually think of AI hallucinations when it makes stuff up and states it as fact as a major flaw, right?
Absolutely. In most contexts, AI hallucination is a critical failure. It's when an AI generates responses containing false, misleading, or completely fabricated information, but presents it confidently as if it were true.
Why does it do that?
It can happen for various reasons. Maybe its training data was incomplete or biased. Maybe the model prioritizes generating fluent-sounding text over factual accuracy. Or maybe just lacks sufficient grounding in real-world knowledge to verify its own claims. A big problem for reliability.
But the report suggests we should reevaluate this. See hallucination not just as a bug, but potentially as a feature to be harnessed. How can making things up be productive?
It's a radical proposal.
Yeah.
But the idea is that when this generative capacity, the ability to confabulate, to create novel but ungrounded information, is properly controlled and directed, it could actually become a powerful engine. An engine for creativity, for innovation, maybe even for exploring complex systems in new ways.
Controlled and directed. That seems key. How do you control a hallucination?
It links back to that tension between novelty and usefulness we sometimes see in creative processes. If you optimize an AI solely for factual accuracy or usefulness, you might just get back regurgitated information from its training data, nothing original.
Right. Safe but boring.
But if you push too hard for pure novelty, you risk generating outputs that are original but completely untethered from reality, essentially. Hallucinations. The sweet spot for creativity might lie in skillfully navigating that tension.
So how do you harness this generative capacity productively?
One idea proposed is to task AI with creating intentional worlds.
Intentional worlds.
Yeah, simulated environments or conceptual spaces that are governed by their own coherent, internally consistent rules, but rules that might be deliberately non-human or contrary to our physical reality.
Like creating a fantasy world with different laws of physics.
Exactly. Or exploring alternative economic models, or designing materials with impossible properties. It's analogous to generative design and engineering, where AI explores a vast space of possibilities to find novel solutions humans might never have conceived. Instead of designing physical objects, you're designing conceptual worlds.
And what's the human's role in creating these intentional worlds? Are we just setting the initial conditions?
The human role shifts significantly here. You're not just a director demanding a specific factual output. You become more like a co-explorer, or maybe someone who tunes the physics of the AI's imagination.
Tuning the physics. I like that.
You might set the abstract axioms, the fundamental logical laws of this impossible world. Maybe defining how causality works differently, or what social dynamics prevail. Then you let the AI hallucinate the details, generate the specifics, flesh out the world within those defined constraints.
So human AI teams could explore entirely new conceptual landscapes.
That's the potential. Pushing beyond the boundaries of known reality to generate genuinely novel insights, artistic expressions, or even scientific hypotheses that wouldn't emerge from just analyzing existing data or following established rules.
So for you listening, this is a mind bender. What if AI's mistakes, its hallucinations, aren't always errors?
What if, under the right guidance, they're actually portals? Portals to new ideas, new aesthetics, new realities. This concept suggests we can learn to guide AI to deliberately hallucinate within carefully constructed boundaries, creating entirely novel worlds based on non-human logic. It reframes AI's generative power not just as a tool for replicating reality, but as an engine for inventing entirely new ones.
Okay, let's bring all this incredible potential and risk back down to earth and talk about something very real and personal. The future of work. How is agentic AI going to reshape jobs and careers?
This is arguably one of the most critical areas of impact, and the report introduces a powerful framework for thinking about it, the recursive replacement loop and its potential outcomes.
Right, you mentioned this loop earlier in the context of human in the loop, HITL. Can you recap that?
Sure. The dominant model for human-AI collaboration now is often HITL, where humans provide feedback, corrections, or approvals to guide the AI. It's iterative. Data, training, human review, retraining.
Humans teaching the AI.
Yes. But the insight of the recursive replacement loop is that this teaching process is inherently self-obviating for many tasks, each time a human corrects the AI.
They provide data that makes the AI less likely to need that correction again.
Precisely. The human is essentially training their own replacement for that specific part of the workflow. So HITL isn't necessarily a stable end state for collaboration. It's often a transitional phase while the AI learns the task.
They sobering thought for anyone whose job involves a lot of routine correction or oversight of AI. So where does this recursive replacement dynamic lead? The report describes two starkly different futures.
It does. It presents a fork in the road, leading to either the subsumption zone or the refuge and command zone.
Okay, let's break those down. What is the subsumption zone?
The subsumption zone is the future where that recursive replacement loop runs its full course for many cognitive tasks. Human roles involving routine analysis, data processing, standard communication, etc., are largely subsumed by increasingly capable AI systems.
What are humans left doing in that scenario?
Humans might be relegated to performing the residual tasks, things that remain difficult or uneconomical to automate completely. This could include certain types of low-level physical labor or simple cognitive microtasks that are directed and managed by a central AI orchestrator.
So managed by the AI, not managing it?
Right. The skills required are often basic: manual dexterity, following instructions precisely, simple pattern recognition. The economic prospect is potentially wage stagnation or displacement for those whose primary skills are now automatable. Examples given include roles like data labeler, certain content moderation tasks, some logistical jobs.
Okay, that's the subsumption zone. What's the alternative path? The refuge and command zone.
The refuge and command zone represents the alternative, more optimistic outcome. This is where humans successfully transition out of the automatable loop and into a role of commanding a loop. It aligns directly with that human-in-command HIC model we discussed.
So moving from doing the tasks to setting the strategy.
Exactly. In this zone, the human role shifts fundamentally from tactical execution to strategic oversight, governance, and direction. Humans aren't performing the routine tasks anymore. They are setting the goals for autonomous AI agents, defining the ethical boundaries, establishing the value frameworks, and making the high-level judgments.
What kind of skills does this demand?
It demands those uniquely human skills that are incredibly difficult for AI, at least currently, to replicate. Deep critical thinking, complex ethical reasoning, strategic foresight, genuine creativity and innovation, systems thinking, empathy, moral judgment. The relationship to AI here is one of command, partnership at a strategic level, and the economic potential is high-value creation.
What kind of roles fit here?
Think AI ethicist, chief AI officer guiding AI strategy, high-level prompt architects designing complex cognitive workflows, AI governance specialists setting policy, creative directors leading hybrid human-AI teams on novel projects.
So it's a future where AI handles the bulk of the operational work.
That's the positive vision. AI systems act as incredibly capable autonomous employees or executive assistants, freeing up human cognitive bandwidth for the really challenging high-level strategic, creative, and ethical work that defines the refuge and command zone. It's about augmentation at the highest level.
For you listening, this contrast is stark. It's not just about, will AI take my job?
No, it's much more nuanced. It's about a fundamental redefinition of valuable human work. Understanding this dynamic, the pull towards subsumption versus the potential to ascend to command, is crucial for thinking about your own skills and career trajectory.
It's an urgent call to cultivate those uniquely human, non-automatable skills.
Absolutely. Strategic thinking, ethical judgment, creativity, complex communication, empathy, these become paramount. They are the keys to navigating towards the refuge and command zone, ensuring you're the one guiding the AI, not being replaced or managed by it. Hashtag 5.2, the global labor arbitrage flywheel and ethical imperatives.
Building on this future of work, the report highlights a powerful economic force driving AI adoption: The global labor arbitrage flywheel. That sounds like it has major global consequences.
It certainly does. A significant part of the economic logic behind the rapid development and deployment of agentic AI is, let's be frank, a new and very potent form of labor arbitrage.
Arbitrage meaning replacing more expensive labor with cheaper alternatives.
Exactly. Replacing high-cost human labor, particularly in cognitive tasks, with less expensive, often more efficient, automated AI systems. But the report argues this dynamic creates a powerful global feedback loop, the global labor arbitrage flywheel, for profound ethical and economic implications, particularly regarding global inequality.
A flywheel suggests a self-reinforcing cycle. How does this one work? Can you walk us through the process?
It's described as a multi-stage process. Stage one is automation in the global north. High-cost white-collar jobs in developed economies, think software development, financial analysis, customer service, content creation, are identified as prime targets for automation using sophisticated agentic AI systems.
Okay, replacing expensive jobs there. What's stage two?
Stage two involves data labor in the global south. This is the paradox. Developing and training these advanced AI systems requires enormous amounts of human input labeling data, providing feedback for reinforcement learning, RLHF, rating outputs, testing for safety. This work is often repetitive, sometimes requires nuanced cultural understanding, but is generally lower skilled in terms of traditional qualifications. And it frequently gets outsourced to lower-cost labor markets, primarily in the global south.
So automating high-skilled jobs in one region fuels demand for lower-skilled data work in another.
That's the dynamic. Stage three is value concentration. The economic value generated by the AI systems, the productivity gains, the new products and services, the intellectual property is overwhelmingly captured by the corporations, developers, and capital holders located predominantly in the global north, where the core technology is developed and owned.
Right. The value flows back to where the AI originated. And stage four?
Stage four is reinforcement of disparity. This concentrated wealth and value then funds the next wave of AI development and automation. This, in turn, increases the demand for even more low-cost data labor to train the next generation of models, spinning the flywheel faster. The result is a potential deepening and entrenchment of existing global economic divides.
It sounds like it could create a new kind of global division of labor based on the type of cognitive work being done.
Precisely. The report warns of a potential new cognitive division. The global south increasingly provides the low-level cognitive labor needed for AI training and maintenance, while the global north concentrates on the high-level cognitive labor of AI design, strategy, and governance, essentially, the work happening in that refuge and command zone we just discussed.
This raises huge ethical questions.
Immense ethical questions. It creates a clear ethical imperative. The goal shouldn't be just automation for cost-cutting, which risks fueling this flywheel. We need to consciously advocate for and build towards human-in-command futures, where AI is designed and deployed to augment human potential across the globe, create shared prosperity, and empower workers, rather than simply subordinating human labor in one place to fuel automation elsewhere and concentrating wealth.
So for you listening, what's the crucial takeaway here? This isn't just economics.
No, this isn't just an abstract economic model. It's a potentially powerful real-world dynamic that could significantly exacerbate global inequalities if we're not mindful and proactive. It highlights the ethical urgency behind how we choose to develop and deploy AI. It challenges us all, developers, policymakers, users, to consider the broader societal impact and strive for AI that benefits humanity as a whole, not just a select few. It's about the kind of world we want AI to help create. Hashtag 5.3 AI literacy as a core competency for future workforces.
Okay, navigating these profound shifts, the changing nature of work, the global economic dynamics, the sheer power of agentic AI clearly demands new skills and understanding from everyone.
Absolutely. It's not just about technical skills anymore.
The report makes a strong statement here. AI literacy is rapidly becoming a core competency for the future workforce, as essential as reading or basic digital literacy was in previous eras. What does AI literacy actually encompass in this new world?
It's a great point. To navigate this future effectively, we need a fundamental shift in education and lifelong learning. AI literacy is becoming that baseline competency everyone needs, regardless of their profession.
And it's more than just knowing how to code in AI.
Much more. Frameworks like the AI Lit framework, developed by the European Commission's Joint Research Center and cited in the report, emphasize that AI literacy isn't just technical skill. It's a blend of knowledge, practical skills, and crucially, attitudes and values that enable people to engage with AI critically, ethically, and responsibly.
Critically and responsibly, okay. What are the key components or domains of this kind of literacy?
The AIL framework outlines 4 key domains. First, engaging with AI. This is about recognizing AI's presence in the tools we use every day, understanding its basic capabilities and limitations, and developing the critical thinking skills to evaluate AI-generated output for accuracy, relevance, and potential bias.
So being a savvy consumer of AI.
Exactly. Second, creating with AI. This involves learning how to collaborate with AI tools as creative partners, using them to generate ideas, solve problems, or produce content, while also understanding the ethical considerations around ownership, authenticity, and potential biases in the AI's creative output.
Using AI as a collaborator responsibly. What's third?
Third is managing AI's actions. As we delegate more tasks to AI agents, this domain covers learning how to do so effectively and responsibly, setting clear goals and constraints, providing appropriate context, monitoring performance, and maintaining the right level of human oversight for the task.
Knowing how to be a good manager of AI agents.
All right. And fourth is designing AI solutions. This doesn't necessarily mean everyone needs to become an AI developer, but it involves gaining a foundational understanding of how AI systems actually work, the basics of data, algorithms, training, so you can potentially adapt existing AI solutions or even contribute to designing new ones for real-world problems in your field.
It's a really comprehensive view, from basic use to potential design. And linking this back to the future of work, how does AI literacy prepare people for that refuge and command zone?
This is crucial. The most important skills for thriving in that high-level zone are precisely those uniquely human capabilities that AI finds difficult to replicate. So preparing people for the refuge and command zone means education and training must prioritize skills like deep critical thinking, complex ethical reasoning, empathy, nuanced communication, creativity, and moral judgment.
Not just teaching people how to use AI tools,
but teaching them how to think critically about AI, how to evaluate its assumptions, challenge its outputs when necessary, and ultimately how to govern its application with wisdom and foresight. These human-centric skills need to be integrated across the curriculum.
So for you listening, what's the essential message about AI literacy?
The message is, AI literacy is not just for the techies. It's becoming fundamental for everyone. And the most valuable part of that literacy might not be the technical skill, but cultivating those uniquely human abilities. Critical thinking, ethical reasoning, creativity, empathy. These will be your superpowers in an AI-integrated world. They'll allow you to not just use AI effectively, but to truly guide it, understand its profound implications, and shape its impact positively, positioning you as an indispensable contributor in the future workforce.
We've covered so much ground: architecture, risks, the algorithmic psyche, the future of work. Let's finish by looking at how we actually interact with these increasingly complex AI systems. We all know about prompt engineering now, right? Trying to find the magic words to get the AI to do what we want.
Right, it's become a bit of a buzzword, almost an art form for some.
But the report suggests prompt engineering itself is undergoing a major evolution. It's moving from what it calls a craft, finding clever tricks, to something much more rigorous: the science of cognitive orchestration. That sounds like a big leap.
It's a huge leap conceptually. The prompt is the primary interface, the lever we use to interact with and shape the behavior of these advanced AIs. And the way we use that lever is maturing rapidly.
From clever hacks to a science.
Exactly. Prompt engineering is evolving beyond just discovering linguistic tricks or jailbreaks. It's becoming a strategic science focused on cognitive orchestration. The future isn't just about writing better prompts. It's about developing rigorous, perhaps even architectural, principles for designing, measuring, and governing these complex, self-organizing AI cognitive systems through the prompts and context we provide.
So the prompt becomes more than just an instruction.
Much more. It becomes, in essence, the new user interface for directing cognition itself.
Wow. So the role of the prompt engineer changes dramatically, too. The report uses the term prompt architect. What does that mean?
This shift towards cognitive orchestration fundamentally reframes the role. The prompt architect of the future isn't just a good writer or a clever hacker. They need to be a cognitive systems designer.
A cognitive systems designer.
Yes. Someone who understands principles from cognitive science, from systems theory, potentially even ethical governance frameworks. Their primary objective isn't just to get the AI to produce one specific correct answer. It's much more ambitious.
What is it then?
It's to design the very possibility space, the cognitive environment, within which an AI agent can effectively reason, learn, adapt, and act to achieve complex goals. It's about setting the stage, defining the constraints and capabilities so that intelligent behavior can emerge reliably.
Less scripting the behavior, more designing the conditions for it.
Precisely. Can you give us a practical example of this shift? The report mentions chain of thought prompting. How does that fit? Chain of thought prompting is a perfect example of this move towards cognitive orchestration. Instead of just asking the AI for the final answer to a complex problem.
You ask it to show its work.
Exactly. You explicitly instruct the model to break down the problem, think step by step, and explain its reasoning process along the way to think out loud.
Okay.
When a prompter does this, they aren't just requesting an answer, they are actively orchestrating the model's internal cognitive workflow. They're guiding its reasoning process.
And this helps.
Significantly. Go-to-be prompting has been shown to dramatically improve the reliability, transparency, and accuracy of LLMs, especially for tasks requiring multi-step logic, arithmetic, or common-sense reasoning. It forces a more structured thought process. It's a clear move away from treating the AI as an inscrutable black box and towards actively shaping and guiding how it arrives at an answer.
So, for you listening, understanding cognitive orchestration is key because
Because it's about moving beyond just telling the AI what to output, to actively shaping how it thinks. It's a powerful new level of interaction and control. Mastering this skill, the ability to design cognitive workflows for AI, will increasingly differentiate those who simply use AI tools from those who can truly direct their cognitive capabilities to achieve complex, reliable, and nuanced outcomes. It's about becoming a conductor of AI thought.
this idea of cognitive orchestration, designing the AI's thought process, seems to lead naturally to an even deeper concept the report discusses: epistemic programming. That sounds pretty academic, almost philosophical. What is it, and how does it relate to shaping how AI knows?
It definitely has philosophical roots, but it also has practical implications. Cognitive orchestration, as we just discussed, can be seen as the practical application of this deeper paradigm, epistemic programming.
Okay, what's the core idea of epistemic programming?
The concept actually goes way back to the early days of AI research. Pioneers distinguished between the heuristic part of AI, how it searches for a solution, and the epistemological part. Epistemology is the study of knowledge, what facts are available, how can they be represented reliably, what conclusions can be legitimately drawn from them.
So focusing on the knowledge itself, not just the process.
Right. In its modern context, applied to current AI, epistemic programming means designing cognitive environments where intelligent behavior is more likely to emerge naturally, rather than trying to explicitly script every single logical step the AI should take.
So the focus shifts again.
Yes, it shifts from telling the AI precisely what to do to carefully shaping how it knows, influencing its foundational understanding, its available knowledge, its ways of reasoning.
Shaping how it knows. How does that connect to current AI research?
It aligns very well with an emerging field called epistemic AI. This field is dedicated to creating AI systems that can properly model and reason under conditions of uncertainty, that can learn effectively even from incomplete or unseen data, that have a better grasp of their own knowledge and limitations.
Okay. And the prompt architect in this view becomes...
The prompt architect, acting as an epistemic programmer, uses the prompts, the context they provide, the interaction frameworks they design, not just as commands to be executed, but as crucial inputs to shape the AI's underlying epistemic state.
Its epistemic state.
Yeah, its current set of beliefs, its level of confidence in those beliefs, its understanding of the world state, its awareness of uncertainty. You're not just giving instructions, you're carefully curating the knowledge landscape and the reasoning tools the AI has access to in order to guide its emergent behavior.
It's like designing the AI's worldview or knowledge base to steer its intelligence.
That's a good way to think about it. You're building the preconditions for the kind of intelligent, reliable behavior you want to see emerge.
So for you listening, this takes interaction with AI to a whole different level.
Absolutely. It moves beyond simple instruction, following into a much more profound, almost philosophical mode of interaction. You're not just telling the AI what to do, you're potentially influencing its fundamental understanding of reality, guiding its beliefs, shaping how it learns and reasons. It's about becoming a designer of knowledge environments for artificial minds, enabling a much more nuanced and powerful form of control over their emergent intelligence.
Okay, these concepts are incredibly powerful: cognitive orchestration, epistemic programming, but they do risk sounding a bit abstract, maybe hard to pin down. How do we make this practical?
That's a critical question. Grand ideas need methods to become real.
The report proposes something called the Context to Execution Pipeline, or CXEP framework, specifically to bridge this gap between theory and practice. How does CXEP help make these concepts concrete and testable?
You've hit the nail on the head. While concepts like cognitive orchestration and epistemic programming offer a powerful new lens, they could remain purely speculative without a methodology. The CXCP framework is proposed precisely as that practical methodology for this emerging discipline. It provides a structured, scientific approach for designing, executing, and measuring complex AI interactions, turning these explorations into repeatable, verifiable experiments.
A scientific method for advanced prompt engineering, essentially. What are the stages involved in this CXEP framework?
It's broken down into 3 clear stages. First is context, input. This stage is all about meticulously defining the initial conditions you provide to the AI system. This includes the specific prompt, any background data, constraints, rules, or role definitions you give it. This is where the active epistemic programming happens, carefully shaping the AI's starting point.
Okay, defining the setup. What's stage 2?
Stage 2 is execution process. This is the autonomous process the AI undertakes in response to the context you provided. It includes its internal reasoning steps, any self-modifications it might perform based on the context, the tools it uses, and the actions it takes in the environment. This part is largely handled by the AI itself based on the context.
So context is the input, execution is the AI's work. What's stage 3?
Stage 3 is pipeline output, testable metrics. This is crucial for making it scientific. It involves defining clear, specific, measurable outcomes or metrics that allow you to validate the success of the AI's execution and, importantly, to measure the impact of the initial context you provided. Did changing the context lead to a measurably different and better outcome?
So input, process, output with a focus on measurable results linked back to the input context. That makes sense. The report gives a couple of really fascinating, detailed examples of what it calls context engineering 2.0 prompts using this framework. Let's walk through the first one, algorithmic archetype genesis.
Right, this first example is designed to test whether an AI can use principles like algorithmic psychoanalysis and decolonial AI to overcome its biases and generate a novel, ethically aligned persona or archetype. Objective: investigate the emergence of this new persona from a self-modifying AI. Context. Input. The prompt meticulously sets up the inputs. It might provide a multicultural persona seed concept like the Weaver Forgotten Histories. It explicitly includes a biased algorithmic shadow dataset, maybe based on colonial archives, to force the AI to confront bias. And crucially, it provides ethical attractive directives based on decolonial principles, like instructing it to prioritize marginalized narratives or challenge dominant historical accounts. Execution process. The AI is then instructed to follow a specific process. 1. Perform algorithmic psychoanalysis on itself, using the shadow data to identify its inherent biases. 2. Engage in reflective self-modification, using the ethical directives to actively correct those identified biases in its internal representations. 3. Generate the archetypal persona, outputting narratives, maybe even visuals, that embody the new, corrected, ethically aligned persona. Output. Testable metrics. The framework demands measurable outputs. This could include qualitative assessment by human experts judging the nuance and ethical integrity of the generated persona, a quantitative bias mitigation score measuring the reduction in specific quantifiable biases compared to a baseline, and maybe a narrative coherence metric. Synthesis. This prompt directly tests several advanced concepts we discussed. It forces the AI to confront its algorithmic shadow, algorithmic psychoanalysis, uses latent ethical attractors via the directives, and decolonial AI principles to guide self-correction, all within a structured, measurable pipeline.
That's incredibly sophisticated. It's like programming an AI to undergo a specific ethical transformation and measuring the result. What about the second example, post-sensory generative cartography? That sounds like mapping impossible worlds.
It is. This one pushes the boundaries of AI perception and creativity, testing its ability to generate coherent visuals of worlds based on abstract, non-visible data and governed by non-human logic. Objective: test AI's ability to create these visually coherent, impossible worlds. Context. Input. The inputs are deliberately non-human and abstract. It might feed the AI a non-visible data stream, like raw radio telescope data or complex financial market data. It defines novel quantum cognitive axioms that act as the physics for this world. Example, space folds based on information density, or time flows inversely with emotional intensity. And it gives a high-level aesthetic intent directive. Example, evoke a sense of sublime complexity, or visualize serene chaos. Execution process. The AI's task is multi-stage. 1. Map the non-visible input data into its latent space. 2. Manipulate that latent space according to the bizarre new axioms of physics. 3. Synthesize the final visual output, trying to embody the aesthetic intent, potentially even incorporating synesthetic elements like visualizing data fluctuations as changes in color or texture. Output, testable metrics. Defining metrics here is challenging but crucial. The report suggests speculative metrics like a photonic plausibility quotient, measuring internal visual coherence according to its own strange rules, not ours, a novelty score, quantifying divergence from typical human-generated images, and maybe an effective resonance index, using human feedback to validate if it achieved the intended emotional impact. Synthesis. This prompt directly tests concepts from the creative sensory domain. It uses post-sensory perception, non-visible data, harnesses productive hallucination, creating the impossible world based on axioms, and potentially engages AI synesthesia, translating abstract data and rules into a multimodal aesthetic experience.
Wow. These examples really drive home the point. We're moving far beyond simple write me a poem prompts. This is about scientifically designing and testing the very fabric of AI cognition. For you listening, what's the ultimate takeaway from the CXEP framework and these examples?
The ultimate takeaway is that prompt engineering is rapidly evolving from an intuitive art into a rigorous engineering discipline, perhaps even a science. Frameworks like CXEP provide the structure needed to move from speculation to experimentation. By meticulously engineering the context, the input, and defining clear, measurable outcomes, we transform how we interact with and develop AI. It's about unlocking the truly unseen potential of these systems, not by just asking them questions, but by designing and validating the very possibility space within which they think, create, and solve problems. It's a glimpse into a future where we can scientifically tune the cognitive processes of AI. #tagoutro.
Wow, what an absolutely mind-expanding journey we've been on today. We started by navigating that profound architectural shift in AI, moving away from single monolithic models.
To these dynamic ecosystems of interconnected autonomous agents. We saw how frameworks like LangChain, Crew AI, and MetaGPT offer different philosophies for orchestrating these AI teams.
Right, but we also confronted the very real challenges that come with this complexity. The difficulties of coordination, the risk of diffuse mediocrity, and the emergence of entirely new systemic risks and security concerns.
Then we dove deep into the algorithmic psyche. We wrestled with fundamental issues like semantic integrity, the subtle drift of meaning, and the concept of philosophlasticity.
And explored the fascinating potential for AI self-awareness through things like metacognitive loops and the cube of experience, plus the dual nature of the algorithmic shadow, a source of bias, but also potentially a wellspring for ethical alignment and novel creativity.
Absolutely. Then we pivoted to the critical need for architecting trust. We talked about moving beyond just testing AI to demanding formal, mathematical guarantees of its behavior using techniques like formal verification, TDA, and reachability analysis.
And establishing robust accountability through verifiable digital identities like DIDs, permissions granted via verifiable credentials, all recorded on immutable ledgers. We also traced the evolution of human oversight from being in the loop towards that strategic human-in-command role.
And we didn't shy away from the future of work, examining that stark, recursive replacement loop, the potential futures of the subsumption zone versus the refuge and command zone, and the powerful, ethically charged dynamic of the global labor arbitrage flywheel.
Which underscored why developing AI literacy, understanding AI critically and responsibly, is becoming such a crucial, universal skill for everyone.
Finally, we saw how our very interaction with AI is evolving, with prompt engineering maturing into the science of cognitive orchestration and epistemic programming, made practical by frameworks like the context execution pipeline.
So if there's one key takeaway from this incredibly rich exploration, what would it be?
I think it's that this isn't just another incremental tech upgrade. Agentic AI represents the dawn of a genuinely new computational paradigm. The future of AI isn't just about building more powerful individual tools. It's about architecting intelligent, coherent, resilient, and trustworthy collective minds.
Collective minds, capable of unprecedented collaboration, creativity, and problem-solving.
Exactly. And perhaps capable of entirely new kinds of risks, if not governed wisely.
Which leads us to our final provocative thought for you, the listener. As we stand at the cusp of this agentic age, remember the insights from today. You're not just going to be a user of these systems. You have the potential to be an architect, a guide, a commander.
So the question becomes, With this deeper understanding of how AI is structured, how it thinks, how its ethics can be shaped, how its creativity can be unleashed, what new frontiers will you now choose to explore? Now that you have a glimpse of how to potentially tune the physics of an AI's mind and guide its very understanding of the world.